Hello everyone, welcome to Pepcoding. So today in this video we are going to discuss question. The question is longest word in dictionary. So what is given in this question? First it is saying that we will be provided with an array of string words, right? Second thing it is saying that find the word of the longest length where all of its substring starting from 0th index exist as a different word in array. So here is a test case given. Let's see what this line means by applying this line on this given test case, right? So here we have the test case, same sample test case. So what that line means is that we have to find the longest word given in this dictionary, right? Let's say this is a dictionary of 7 words. So we have to find the longest word where all its substrings are present as an individual word. So what this means is, let's take this as banana as an example. BA, right? If we take banana as an example and if we try to search for all its substrings, so what are going to be its substrings, or let's say what are going to be prefix for this banana word, right? Let's start from this point. For A, the prefix is going to be these thing, that is this substring. That is, for last A, let's give them indexes 1, 2, 3, 4, 5 and 6. For A present at 6th location, for A present at 6th index, what is going to be its prefix? That is what is going to be its substring. That is going to be BANAN, right? 1, 2, 3, 4, 5. So for this A at 6, the substring or the prefix of this A is going to be this string, right? Similarly, if we take this N, that is at 3, for N at 3, the substring or the prefix is going to be what? BA, right? That is 1, 2. So now if we see it in a proper manner, that is starting from B to and then going to A, then how it is going to look? I'll erase this not to, so that you will not be confused. For this banana, the prefix is going to be something like this, or all the substrings of this banana are going to be something like this: BA, BAN, BANA, BANA, and banana itself, right? Banana itself. So now if we try to search for all the substrings of this banana in this given dictionary, then we can see that only this thing, that is the banana, is itself present, but not the other strings, right? Not the other strings. But similarly, on the same hand, if we take an example for, let's say, apple, right? We can see that this is the longest word in the dictionary, but it's all the substrings are not present. So this cannot be our valid answer. But let's see what others can be our valid answer. If we see this apple, or let's say if we see this apply, can it be our valid answer? Let's write all its substring. It is going to be A, AP, APP, APPL, and APPL, right? So here we can see that if we compare all these substrings with the given words in the dictionary, let's see if all the substrings are present or not. A is present, right? Then let's search for this. Next thing is going to be APP. APP is also present. APPL is also present. AP is also present, and apply itself is also present. So from this we can conclude that there is a word that is present in this dictionary where all its substrings are already present. That means, and all those substrings are individual word. Let's say, what does this individual word means? That this A is an individual word. A is as in substring is also an individual word. APP is an individual word in this dictionary, and as being a substring of this apply, APP is also an individual word if we consider it as a substring of this apply, right? And others are also following the same property, right? So we can say that this apply is a possible answer, right? It holds a value, or it holds the chance to be a possible answer. But if we look for another word, or if we go further and look for this apple, it is also having all its substring, right? If we say that A, AP, APP, APPL, and APPLE, right? Here we can see that A is present, A is present, A is present, AP is present, AP is also present, APP is also present, APPL is also present, and Apple itself is also present, right? So with this, we can say that this Apple is also a valid answer. So here we are getting two answers, right? Apply and Apple. But now let's see that what is further told us in the question. It is saying that if there are multiple answers with the same length, return one which is the smallest lexicographical order, right? And if there is no valid answer, just return an empty string. So what is this meaning? What this sentence means is that if we are getting two answers that are having same length, have the possibility or are the possible answers, that is apply is also a possible answer, apple is a possible answer, then return the answer or return that word that is that is smaller if we consider the lexicographical order, right? So here we can see that here we can see that E is smaller than this Y. Therefore, lexicographically, Y is bigger than this E. That means Y comes after E. Therefore, we have to return this apple one, that is with this the word that is ending with this E, right? Therefore, we have to return this apple. So with this, I hope the question was clear to you all. Now, let's try to discuss the solution. First, if we try to do it with a brute force method, what can be the brute force method? We can just go iterate on every word and check for the longest subsequence or longest substrings for a word. Like if we take apple, we can just go and check for each and every word that if the substring is a substring of apple is present in this or not, right? This is the first thing we can do. Now let's see for the second thing, that is the best approach that we can use. That is going to be what? Here, if we try to observe something, we can see that this part, right? Let's highlight this part, and this part. These two parts of our possible answers are equal, right? Are common in nature, which means that we can use these two parts, or we can say that we, instead of traveling these two parts again and again, that is for two times, let's travel them only once, and where these two parts are changing or are having two different answers, let's just give those two parts different places, right? What I'm trying to say is that let's use the concept of try. Let's make a root node first. Let's use this example, that is use this test case. Right, first take this A. We took this A as an individual word, right? A is an individual word, so this A return of this A is over. Now this banana, let's take this banana where B is the starting letter, A, N, N, A, right? Banana. Here this A is the ending letter, which means that this banana is an word where B is the starting letter and A is the ending letter. But this is not an valid answer because this this B, A, N, A, N, these are not the individual words that are present in this given dictionary, right? Now let's talk for app, that is P, P. Here we can see that this P is the ending letter, right? Now let's check for this APPL. Now here if we see from a root node, we are able to see that A is common, A is common. We already have this P, we already have this P. We again have one P. So what is not there? This L is the only thing that is not there. So we can just add this L and we can just use this rest of the things, right? Here this L is going to be the ending point. Similarly, if we come for this A and P, that is AP, Here we can see that from our root node, we already have A and we already have P. Then just consider this P as an word, or let's just consider this P as an ending letter of a word. So that word is going to be what? That word is going to be AP, right? And next, if we go for this apply, we can see that there is an word that is coming, or that is actually coming, we can say that there is a word that is coming after this substrings, right? And there is another word that is coming at this place, right? So with this, what I am trying to say is that there is a word, or there are two words, or I'll just try to rephrase this thing again. We can say that these thing, or these substrings are common, and the work is being divided for this L. That is, L is having two children, that is E and Y, where this part, that is, this part is making one word and this part is also making one word. So here we can see that this particular part is common part, or we can call it as a shared node, right? And the work is being divided for just E and Y. So what we can do, we can just travel from this route, we can just travel from this route and start making our answer, right? And as we travel, we are going to actually use this concept, or this thing of travel and change. We are going to use this travel and change strategy, where we are going to make our answer as in global or static answer, and we are just going to travel through all the substrings, and we are going to change, we are going to make changes in our answer, where we are going to store our answer in which manner, in a lexicographical manner. That is, first we are going to start from A, and then we are going to move from A to Z. Therefore E is going to come on this left side of L, and Y is going to come on the right side of L, right? Why is this happening? Because we are traveling in lexicographical order. So with this, if I start making my answer, that is, from E, I am going to use my DFS. That is, from E, it is going to return to L. From E, it is going to return to L. And from L, it is going to come to Y. But as we are moving in lexicographical order and we are using DFS at this particular point, what is going to happen? Or when we are going to change our answer? Our answer is going to be only changed when, or when only updated when our answer's length, that is, if we say that if my current length, that is current words length, if my current words length, that is after traveling till here, till Y, is going to be greater than my answer's length, then I am going to update my answer, right? Update my answer. So what I'm trying to say is, I'm trying to say that as we are moving in lexicographical order, right, we are going to store our answers in lexicographical order. So first, what is going to happen? First this A, P, P, L is going to be created, right? And then it is going to check for A, P, P, L, Y. That is, from the C, it is going to check for Y. But as in lexicographical order, E is going to come before Y. Therefore, it is going to consider this as an valid answer. But if there was a case where this Y was going to have some word or something like, let's say A, B here, right? If Y was going to have, or instead of A, B, just let's say Y was going to have B, some B here, then the word, let's say it was something like APPLYB, appleb, right? Anything like this. That doesn't make any sense, but just for now, we are taking an example that if there was a word something like this, then our longest substring, or longest answer, or longest word is going to be what? our longest word was going to be this APP YB. Therefore, after coming from here, that is after applying DFS here, it is going to check for Y. It is not going to update. It is not going to update for this Y. But when it goes to this B, what it is seeing that our answer's length, till now our answer is apple. But now my current length, that is current word's length, is greater than my answer's length. Then it is going to update, because we have to do what? We have to return the longest length. We have to return the word of the longest length, right? Longest length of the substring starting from 0th index exists as a different word in an array, right? So if there was a word something like this, if there was B also present here, then this B was an individual word. Also B was something like this substring, right? So substring for this apply or this word was going to be this apply and this B, right? Therefore it was going to be the longest substring, right? Therefore our answer is going to be updated from this apple APP LYB, right? So I hope this is clear to you all. So therefore, but as currently we don't have this thing, we don't have this applet, therefore it is not going to update our answer. It is going to keep answer as apple only, right? Because we are going to store in lexicographical order. So with this, I hope this is clear to you. What we are going to do, actually we are going to just use this word, that is or we can say that use this part as in common part, or a shared, we are going to store this in a shared node, and where the work is being divided, we will just work for that thing and we are going to apply DFS over there. So let's now try to code this thing and see what is going to happen while we what is going to be a code structure for this thing, right? So let's code this question. Sorry. So here we have to start from this function. First we need a node, but before having a node, let's create a node class. So static class node, and this class is going to have node child, an array of size 26, because there are 26 letters, or say 26 alphabets, and then there is going to be a string str, right? Now let's create a node. Root is going to be a new node. This is going to help us to travel, right? Now from here, what we have to do, we want to do two things. First, we want to travel, and we want to store this, that is we want to create this kind of links, that is of this common nodes, that is APP LE LY and banana, that is we want to create common tries for all the given strings in the test cases, right? So to do that, we have to traverse on all this given strings, right? So to do that, let's start for not int string s in words. What we have to do, first we have to insert this root and s, that is we are calling a function called as insert, which is taking this root and this string as an input, and this is going to store, or this is going to create this kind of links, that is it is going to create nodes with these alphabetic values, that is for a it is going to create this, for n this is going to create, let's say for banana it is going to create something like this, right? Something like this we have to do. And after this we have to call a function called as DFS, and from here we have to return answer, right? So to return our answer, let's create our answer. It is going to be static string called as answer. Initially, let's keep it as an empty string. Right, now we have these two functions, that is first insert function and second one is DFS function, right? So let's create those two functions. Public static void insert. This is going to take a node root value. This root value is nothing but our current node, that is that this node value or this root value is telling us that currently we are standing at this particular node. So we will name it as node current, and this is nothing but a string s. Sorry, right? Now we want to travel. We want to travel to this. Let's say this is our word. This is our string value. We want to travel on every alphabet of this string, and we want to create a respective node, something like this, right? So we are going to travel, that's I0, I is less than s dot length and I plus plus, right? Now to create these things, we want what? First we want to extract single characters, right? First these characters. So we are going to use char ch is equals to str, or sorry, s dot char at I. This is going to give us the characters. Let's say this is going to give us the character for this. Let's say for apple, this is going to give us the character A, right? If we initially start from here. Now the second thing we want to check is that if the current character, that we are currently standing on is already being included in this list or not. If it is already being included, then why to include it again? For example, for this case, let's say this, for this apple case, or let's say for app till this L, A was included, then app was created, right? App was created, and after that this app was created, right? So it is going to check that if this app is already created because of this app, right? This app was already created, then it is not going to again create new p. That is, it is not going to do something like this. First it is going to create a pp, and again it is going to create a and p. It is not going to do like this. It is going to check the we are going to check if this a is already being created and it is again being repeated, then let's not create that. If p is already created, then let's not create again, right? Why we are checking in this? If we notice, or if we have a doubt that we are doing something like this, but here in this for this banana, this a and n are also being repeated, then why we are not taking them only once? Because this banana is one whole word, right? There's actually not there's actually not a substring. This ap is a substring of this app, right? And this app is a substring of apply, or this appl. Therefore we can use these things, but banana doesn't have any substrings other than itself. Therefore it is going to come whole itself, right? So we are going to check if my current child ch minus a is present or not. If it is not present, then do what? Then create, sorry, then create this as a new node, right? What we are doing, we are checking that if this a is not present, then create, or let's say for this, for initially starting, a is not present, it is going to create this a. right? It is going to create the same. And if it is already present, then just update it, right? Then just update this with my current node, that is current is equals to this. Now after this, current str is going to be updated with s, right? This s is nothing but a newly created string. Now there is a second function, that is dfs function. So let's create that function, static dfs void dfs, and this is going to have what? This is going to have just one node value. So node root. Now this is going to travel through this whole node, that is it is going to travel to all these created nodes, and it is going to use, or it is going to see that if the current answers length is greater than the previous created answers length or not. That is, it is going to check for this thing, right? So we are going to do that only. It is going to travel to all these nodes. Let's name them as child child in dot childs, right? And it is going to check if, first thing it is going to check is if my child is not equal to null, and then this child string, that is this string or str, or the string that it is containing, that is this answer string, is not an empty string, right? It is going to check these two things, that is not an empty string. Then and then only we are able to check, that is it is going to avoid the null conditions, that is whenever there are no words to check, it is not going to check, right? We are actually reducing the checking timing. We are just going to check for the valid answers, right? So now what we are going to do, if we are going to apply this condition, right? If my child dot string length is greater than my answers length, then it is going to update, which means answer is equals to my child.str, right? And again, after doing this, let's apply dfs to the childs, dfs to child. All right, through this it is going to check for every node, right? It is going to check for every node. So with this, the code is almost done. Let's try to submit this code or run this code to see if there are any errors. Okay. Line number 23. Line number 23. Instead of this, it is going to be dot. Okay. Character C, it cannot find the symbol. Okay, caret. There is a spelling mistake here. CHR. Okay, it has been rejected. Let's see. See, it is actually saying it is being rejected. Let's see where it is going wrong. Childs. Okay, instead of this empty string, actually it is going to be null, because this is a pointer and we are going to check for the pointers. Let's try to, yes, now it is being submitted. It is being giving us the correct output. Let's try to submit this code, and every test case is passing. So what was our mistake? Actually we were checking for the empty string value, but it was a pointer. Therefore we have to check for the null. We have to check if the position or if this pointer is null or not, right? So with this, I hope the code is clear to you all. So thank you for this video, and I hope the solution was also clear to you all. What we did actually, we created a try and we shared the common nodes, and we just applied DFS, that is when there was two different childs, or there was two different paths, let's say, or there was when there was multiple children, when there was this multiple children, we have to apply DFS, and we have to just update our answer only when our current answer is current answer's length is greater than our previously created answer, as this answer is going to be a static answer, and we are going to use this travel and change method. Then travel and change method, it is going to be updated only when our current answer is greater than this. And let's see that in that case, when I said that we have to store in this lexicographical order, what if instead of this, if we just do this, that is, if our current answer's length is greater than or equal to our answer's length, then what is going to be change in my answer? Let's try to see that if it is going to give me, sorry, if it is going to give me this apply as an answer or not, because apply is also having the same length, right? Currently we are not talking about the lexicographical order. So let's write here greater than equal to. Let's try to run this code now, and here you can see that apply is being coming as an answer, right? So what is happening actually, apply is also first in our answer apple was told, right? But now after after calling this DFS, what happened, there was a new answer created, that was apply. Now when we put this equal to condition, what it was doing, it was just checking for the length, it was not checking for the lexicographical order, that is, it was not checking for the A to Z kind of thing. Because when we eliminate this condition, that is when we don't put the equal to sign, what it is just doing, it is going to apply changes, or it is going to change our answer only when there is a word, let's say apply, or let's say ABC, right? There was something word something like this, it is going to change only after when this, let's say it was our answer and it was our current answer, only when the length of this current answer was going to be greater than our answer, then and then only it is going to change. And because of this thing only, because of this equal to sign only, and this travel and change property, our answer was being stored in lexicographical order. So with this, I hope that this thing is clear to you. So thank you for this video. Let's meet in the next video.